For over 4 decades, a spacecraft named Voyager 2 has been moving steadily away from the Sun, heading into the vast darkness of deep space. As it travels farther, sunlight fades and becomes less useful as a power source. The surroundings grow colder, emptier, and more distant from anything familiar. Temperatures drop to extreme lows where almost no heat remains, creating an environment that feels silent and endless. The journey began in 1977 when NASA launched Voyager 2 with ambitious goals. It was a relatively small robotic probe, but it was designed to explore regions no spacecraft had reached before. At the time, the outer planets were aligned in a rare configuration, allowing the mission to take advantage of a technique known as gravity assist. By passing close to massive planets, the spacecraft gained speed, like a slingshot, without using much fuel. This strategy enabled it to travel much farther than originally planned. Its first major stop was Jupiter, the largest planet in the solar system. As it approached, it sent back stunning images that transformed scientific understanding. It captured enormous storms, including the Great Red Spot, which is larger than Earth. It also revealed intense radiation belts and a powerful magnetic field. During this encounter, new moons were identified, and active volcanoes were observed on Io, making it one of the most dynamic moons known. After completing its observations, Voyager 2 moved on to Saturn. Famous for its bright rings, Saturn appeared in incredible detail. The spacecraft showed that the rings are made up of countless small particles. It also helped identify additional moons, deepening knowledge about how planetary systems form and evolve. The next destination was Uranus, a distant and unusual planet. Before Voyager 2 arrived, very little was known about it. The planet appeared as a pale blue sphere, rotating on its side. This extreme tilt causes seasons that last for many years. The spacecraft recorded powerful icy winds and discovered that its magnetic field behaves in unexpected ways. Continuing its journey, Voyager 2 reached Neptune, the final planet it would closely study. There, it observed massive dark storms moving across the atmosphere, proving that the planet is active. It also measured incredibly fast winds, some exceeding 1,200 miles per hour. The fastest recorded in the solar system. After passing Neptune, the spacecraft moved beyond the known planets into a distant region filled with ancient, frozen objects. Many believed the mission would have ended long ago due to its age and limited technology. Despite this, it continues to function. Its power comes from a nuclear source that gradually weakens over time, so engineers carefully shut down non-essential systems to conserve energy and keep key instruments running. Even now, Voyager 2 continues to send signals back to Earth. These signals travel billions of kilometers through space and arrive extremely faint, requiring powerful antennas to detect them. Each message takes many hours to reach Earth, yet the information remains incredibly valuable. The spacecraft has also helped scientists study the heliosphere, a vast bubble created by the Sun that surrounds the solar system. This protective region is not perfectly shaped and changes as the solar system moves through the galaxy. As a result, the amount of cosmic radiation reaching Earth can vary over time. At one point, the mission faced an unexpected moment when communication suddenly stopped. Scientists feared it had finally gone silent after so many years. However, the signal eventually returned, likely due to aging equipment. Before this interruption, Voyager 2 had recorded unusual data, including strange magnetic changes and bursts of energy. Even after decades in space, it continues to provide new insights. Its journey shows that space is still full of unknowns and constant surprises. As it moves deeper into the cosmos, scientists remain ready to receive every signal, knowing each one could reveal something new. As Voyager 2 continues its journey into the unknown, it has now reached a region where the influence of the Sun begins to weaken significantly. This boundary is known as interstellar space, a place where the solar wind slows down and the pressure from distant stars becomes more noticeable. Crossing this invisible border marked a historic moment, as the spacecraft officially entered a realm no human-made object had explored before. In this distant region, the environment is unlike anything within our solar system. The charged particles coming from the sun decrease, while cosmic rays from outside grow stronger. Voyager 2's instruments began detecting these changes, helping scientists understand how our solar system interacts with the rest of the galaxy. It revealed that this boundary is not a simple line, but a complex and shifting zone influenced by solar activity and interstellar forces. One of the most fascinating discoveries came from its measurements of plasma, a form of matter made of charged particles. The spacecraft detected differences in temperature and density that suggested it had truly crossed into interstellar space. These findings provided direct evidence of conditions beyond the sun's protective bubble, something scientists had only theorized about before. Despite its incredible distance, Voyager 2 is still in contact with Earth. However, communication has become increasingly difficult. The signals it sends are extremely weak, and even small technical issues can disrupt the connection. Engineers must rely on decades-old technology and carefully timed commands to keep the spacecraft operating. Every instruction takes hours to arrive, and any response takes just as long to return. As power levels continue to decline, more systems are gradually being turned off. Instruments that once collected valuable data are now silent, sacrificed to keep the most important functions alive. This slow shutdown process is carefully planned, allowing the mission to continue for as long as possible, even as its capabilities decrease. There is also a deeper, symbolic side to Voyager 2's journey. Onboard the spacecraft is a golden record, a message intended for any form of life that might one day encounter it. This record contains sounds, images, and greetings from Earth, representing humanity's attempt to communicate across the vastness of space. It serves as a time capsule, carrying a piece of human history far beyond our solar system. As it drifts farther away, Voyager 2 becomes more than just a scientific instrument. It becomes a silent traveler, moving through a region where no signals, no rescue, and no return are possible. Its path will continue for millions of years, long after its systems have gone quiet. Yet even in silence, its legacy will remain. The data it has already sent back has changed how we understand the outer planets, the heliosphere, and the boundary between our solar system and the galaxy beyond. It has shown that exploration does not always require speed or power, but patience, precision, and vision. Some scientists believe that as Voyager 2 moves deeper into interstellar space, it may encounter unexpected phenomena. Subtle shifts in magnetic fields, unexplained particle bursts, or unknown structures could still lie ahead. With each passing year, the chances grow smaller, but not impossible. For now, Earth continues to listen. Massive antennas remain pointed toward the darkness, waiting for the faint whisper of a signal traveling across billions of kilometers. Each transmission is a reminder that something built decades ago is still out there, still exploring, still sending back pieces